All right, so today we're going to be looking at two new functional groups that we're adding to our organic chemistry repertoire. We're going to be looking at alcohols, and then we're going to look at halocarbons. So starting off with, the first thing we should notice is this is the first time we have elements that aren't carbon and hydrogen. We get to add oxygen into the mix. So really, part of this should look familiar, so I'm going to look at this molecule right here. And if I tell you it's an alcohol, it should be really obvious what makes something an alcohol. The fact that it has this OH group right here, that OH group, the technical term for that would be a hydroxyl group. That's a term that we heard back when we did acids and bases. Typically, hydroxyl groups are OH negative, but that just means that they can form a bond. So in this case, what this molecule represents right here, we have a carbon here, we have a carbon here, and that carbon is single bonded to this hydroxyl group, this OH right here. So now the big question is, how do we name alcohols? So the way that we're going to do that is two carbons here. We're going to start with that. If you look at your prefix list, a carbon chain of two carbons, let's go 1, 2, or if we're going the other way, let's go 1, 2. Since one of the rules is going to come up here. Two carbons, we're going to call that an F. Right away, that's the hard part done. Then we have this OH group here, and so to indicate that this molecule here is an is an alcohol, just kind of give it away. Typically, the word for this would be ethanol. We would go ethan, because our carbons are single bonded together, and I could maybe do that a little bit better. All right, so here's my ethan. And in this case, I need to indicate where that hydroxyl group is. So we're going to use our numbers again. In this case, there's only one option where that could be, and that's on carbon number 1. But now the big kicker, how do we know that this is an alcohol by the name? We're going to end it with OL, ethanol, ethan-1-ol. Just indicates that that hydroxyl group is on carbon number 1. So if I go over here, if I have 1, 2, 3 carbons, and we know that we need to number things using the lowest number possible, so let's just put that 1 there, since the only thing attached to this chain is this hydroxyl group, hydroxyl group there. So once again, prefix for 3 is prop. Our carbons are all single bonded together, so that's propan. If we had a double bond here, it would be propen with an en. Propan. Hydroxyl groups on carbon number 1, 1, OL. OL tells us it's an alcohol. It has that OH group there. This molecule here, number of carbons is still 1, 2, 3, or 1, 2, 3, doesn't really matter for this case. So this one would be propan. Once again, we need to figure out which carbon of that alcohol group that hydroxyl group's on. In this case, it's on carbon 2, so propan 2 OL. All right, so let's look at a molecule that has a lot going on. So 1, 2, 3, 4, 5, 6. Let's go 7. I like the hepts. Then let's go. We're going to go double bond here. Let's have a methyl coming off there. And let's go. We're going to go with an OH group there. All right, so now let's name this thing. So first thing first, figure out our longest chain. Looking at this, I'm going to go 1, 2, 3, 4, 5, 6, 7. So we know we're working with a hept molecule. All right, next question. Do we have any single or double bonds? We do. We have a double bond right here. So we know that we're going to be working with En. We're working an alkene, so we need to get an En in here somewhere. So numbering wise, for the rules here, double and triple bonds always get the lowest number. So I can go 1, 2, 3, 4, 5. Let the double bond start on 5, or let it start on 1, 2. Let's go that way. 1, 2, 3, 4, 5, 6, and 7. All right, so now it's hept 2 N to indicate that double bond. Okay, so I've taken care of that part. Next, I need to indicate that hydroxyl group. So it ends with OL. So hept2N dash. Let's see, that hydroxyl group is on number 5. So 5 OL. Okay. We're actually probably not going to name it like that, but in this case, let's just make it crazy. All right. And then we have 1, 2, 3, 4. We have a methyl group on 4, so 4 methyl. Squeeze that in there. All right. Typically, though, you're not going to see it like this. You're only going to have one thing modifying the end of your name. So really what this would be is on your cheat sheet, what you'll find is that OH group is an alcohol, but it's also a hydroxy group. This typically is going to be more accurately named 5-hydroxy. Pretend that's hydroxy. 4-methyl. I don't know if I'm going to get that in. Hept 2-ene. Typically, the point I'm trying to make here, and I'm going about it the wrong way, having 2 modifiers at the end, that doesn't work. So if you have a double bond and a hydroxyl group, you're just going to name the hydroxyl like it's kind of a methyl group there. The other thing I do want to touch on is, let's say that we have 1, 2, 3, 4 OH here, OH there. Same rules are going to apply. So we have we have 2 hydroxyl groups on here, 2 alcohol groups. And so then when we name this, it doesn't matter which way we number our carbons. This 1, 2, 3, 4. 4 is a butane. The carbons are all single bonded together. This time I would go 2, 3. To indicate that there are those 2 hydroxyl groups there, we would just go diol. Diol. Butane, diol. Butane 2, 3, diol. All right, and that's alcohols. Pretty easy. Once again, you just number it just like you would an alkene or an alkyne. Or if you have a double or triple bond in there, you're not going to add another thing at the end. You're just going to call it a hydroxyl group. But let's move on to halocarbons. They're a little bit easier. This one's going to go much more straightforward. We're going to look at this molecule right here. First things first, count up the number of carbons. 1, 2, 3, 4. So 4, so my root here is going to be a bute. They're all single bonded together, so I know it's at least butane. In this case, when we're working with halocarbons here, so we're not working with OHs anymore, we're not working with alcohols, we're working with a different class of organic molecules. For halocarbons, the way we indicate it is we name our parent chain, so in this case butane. And now I just need to go back, and just like we did with the branching alkanes, where we had to identify where the methyl and ethyl groups were, we just have to do the same thing with the halogens here. So halocarbons are carbon chains with halogens on them, or elements, non-metals from column number 7. So in this case, I have a fluorine here. And just like when we had a methane group on a chain, we called it methyl. If we have a fluorine on our chain, we're going to call that fluoro. I can make that look better. Maybe. And since this is organic chemistry, I just can't call it fluorobutane. I need to indicate what number it's on. Once again, use the lowest number. 1, 2, 3, 4. Let's make that 2 better. There we go. So this is 2-fluorobutane. All right, so this molecule right here, count the longest carbon chain. So that's not a carbon, that's a chlorine. So 1, 2, 3, 4. So we're still working with the bute. My carbons are all single bonded together, so butane. Let's see. I have 1, 2 chlorines on here. So to indicate those 2 chlorines, I'm going to go with dichloro. There's a space there. And like always, I need to indicate what carbons those chlorines are on, so I can go 1, 2, 3, 4, or 1, 2, 3, 4. Lowest numbers win, so 1, 2, 3, 4. So 1, 2, dichlorobutane. All right, and over here, 1, 2, 3. If I go up, that's not that long. 1, 2, 3, 4. 1, 2, 3, 4. Longest chains, once again, bute. I kind of had a theme going with this set. The carbons are all single bonded together, so butane. So now I have two things. I have a bromo group here. And up here, methyl group. Now when I go to put my functional groups in the name, just like we did with methyl and ethyl, I'm going to go with alphabetical order. So in this case, I'm not going to be too picky about the numbering, but I want my bromine, which comes first in the alphabet, to have the lower number. So we're going to go 2-bromo. Apologize for the handwriting there. 3-methyl. You know, that's pretty messy. Let's just rewrite it down here. 2-bromo, 3-methyl, butane. Cross that out. All right. So once again, the only thing that we're adding is with the halocarbons, they work just like branching alkanes. Whatever the carbon group that we added onto our chain, we just indicated them in front of the name of the parent chain. So like for this one, we had a fluorine on number 2 out of this 4-carbon chain, so it was 2-fluoro-butane. Or if we had 2 chlorines on there, we called it dichloro. 1-bromine, bromo. And then just like with ethyl and methyl, when we name it, we go in alphabetical order of the functional group. If I go up to the alcohols we worked with, if there's only one hydroxyl group on there, one OH group, we still name the parent chain. So in this case, it was ethan, because 2. Eth for 1, and because it's all single bonded. Then we just ended it with OL. That tells us it's an alcohol. That tells us there is an OH group somewhere. If we had a special case where we had a double or triple bond and a hydroxyl group, then we're not going to end it with OL. It just gets too messy. We just name it a hydroxyl or hydroxy, just like we would a halocarbon down there. All right. Practice problems are up. If you have any questions after watching this, feel free to ask me.